Hello friends, welcome to BBSbaba Physics. Today we are going to discuss about Zeeman effect. We'll go through the few pages of book, then I will go through the notes and what are the important aspects of Zeeman effect. For example, Thomas precision is very important. Every year a question is coming again and again about that. So the types of Zeeman effect, longitudinal and the polarization, everything we'll try to discuss in this video. Now let's moving ahead. Zeeman in 1896 ये सब हो रहा है. A light source giving line spectrum is placed. जो line spectrum already see the Zeeman effect. Due to Zeeman effect we get components, okay, but जो in spin orbit coupling the levels are split into different levels, and the lines transitions are called lines, not components, and in no case the lines will be called lines in Zeeman effect. That would be called components. Okay, we'll discussing those as well in the coming ahead. So let's move ahead. Is placed in external magnetic field is very important. यहाँ पे एक्सटर्नल मैग्नेटिक फील्ड में हो रहा है, वहाँ पे इंटरनल मैग्नेटिक फील्ड में होता है, चाहे वो एलएस कपलिंग हो चाहे वो स्पिन ऑर्बिट हो. ओके, so the lines emitted by the atoms of the atom are split into a number of polarized components. This is very important keyword, polarized components for field less than several tenths. या डेटा मेंशन करना several tenths of a Tesla. The आपको याद है we calculated in सोडियम वाले एटम में इंटरनल स्पिन ऑर्बिट कपलिंग विच वाज हैविंग 24 समथिंग टेस्ला, इट्स वेरी ह्यूज, बट यहाँ सेवरल टेंथ्स 1/10 ऑफ टेस्ला से भी कम के आसपास. इस प्रोपोर्शनल टू स्प्लिटिंग जो है प्रोपोर्शनल टू द जितना मैग्नेटिक फील्ड के प्रोपोर्शनल होगा. दिस इफेक्ट ऑफ मैग्नेटिक फील्ड ऑन द लाइन स्पेक्ट्रल लाइन इज कॉल्ड जीमान इफेक्ट. तो आपका जीमान इफेक्ट का डेफिनेशन हो गया, राइट. नाउ मूविंग एट a singlet मतलब क्या, s is equal to 0, right. A singlet line is viewed at right angle. A singlet line when viewed जब right angle to the magnetic field, ये magnetic field का डायरेक्शन है ऐसे और आप ऐसे देख रहे हैं, right, splits into three plane polarized components. ये बात ध्यान रख लीजिएगा, three plane polarized components में टूट जाता है, ठीक है. थ्री प्लेन पोलराइज्ड कंपोनेंट्स. सेंट्रल अनशिफ्टेड, सेंट्रल वाला अनशिफ्टेड होगा, जैसे यहाँ सेंट्रल अनशिफ्टेड, ठीक है. And with electric field vibrating parallel to the magnetic field, a central electric field जो है vibrating parallel to the magnetic field, ठीक है. magnetic field इधर है तो उसी के parallel vibrate करेगा, ठीक. और called pi components अगर, और and for those line equally displaced either side of the vibrating field is called magnetic sigma components, ठीक है. So now pi components आपका 0, delta m is equal to 0 corresponding to pi component, delta m is equal to plus minus 1 is equal to sigma components, right. तो ये अपने देख लिया, आगे भी देखेंगे. This is called normal triplet. Normal triplet कहते हैं. तो for example अब जो normal triplet का concept है कि singlet states में जो when you see in perpendicular right angle to the magnetic field split into three plane polarized components, ठीक है. आगे बढ़ते हैं. It's called normal. And now when we see ये जो आपका सोडियम D1 D2 lines है, D1 D2 lines, तो D1 D2 lines are again split due to external magnetic field. तो यहाँ पे 4 है और यहाँ पे D1 के लिए 4 था और D2 के लिए 6 था, right. So the fine structure components of multiple spectral line, this is called, वहाँ पे singlet spectral lines कह रहे थे, यहाँ multiplet spectral lines will however so it's a complex Zeeman pattern, इसी को anomalous Zeeman pattern भी कहेंगे. For example D1 and D2 components of sodium yellow doublet gives 4 and 6 lines respectively, right. This is called anomalous and the Zeeman splitting is smaller. ये बहुत important keyword है, ये बहुत ही ज़्यादा is smaller than the fine structure splitting, smaller than the fine structure splitting, ठीक है. तो हमने देख लिया, आगे बढ़ते हैं. ये स्प्लिटिंग बाद में भी देखेंगे. अभी जस्ट मैं आपको जैसे ये दिस वन जो फॉर एग्जांपल D1 D2 लाइंस कैसे आ रहा था, 3s D1 3s और 3p. तो s वाला तो जो है 2s हाफ, राइट. D1 D2 लाइंस और p 3p कंपोनेंट L इज इक्वल टू 1 और S इज इक्वल टू हाफ, तो प्लस हाफ माइनस हाफ, तो 2p 3/2, 2p हाफ, 2 कैसे होता था, S इज इक्वल टू हाफ है तो 2s प्लस 1, तो ये सब ठीक है. नाउ ड्यू टू अब यहाँ पे मैग्नेटिक फील्ड अगर लगा देते हैं तो ये कंपोनेंट्स में स्प्लिट हो जा रहा है. 3/2 3 कंपोनेंट्स ये है, तो माइनस 3/2 से माइनस 3/2, राइट. तो 4 कंपोनेंट 3/2 1/2 माइनस 1/2 minus 3/2. This is MJ और GJ landed G factor होता है, will calculate ahead. So ये इस टाइप की लाइंस आती है. This is called pi is equal to delta MJ is equal to 0 और delta MJ is equal to plus minus 1 pi components. delta MJ is equal to 0 देख लीजिए कैसे, यहाँ ये वाली लाइंस को ऐसे रिप्रेजेंट कर रहे हैं, तो यहाँ 1/2 है, 1/2 से लेके 1/2 आया, तो डेल्टा एम जे इज इक्वल टू 0, राइट। आगे बढ़ते हैं। नाउ ये सब बात आप देख लीजिएगा, इंटेंसिटी ऑफ द जीमान कंपोनेंट कैसे गवर्न होता है। मैं आपके कंसेप्ट पे आता हूँ, वी आर स्टार्टिंग अगेन। For example, Zeeman effect is the splitting of an atomic spectra into several polarized components, मैंने definition several polarized components in presence of weak external magnetic field। ठीक है, ये डेटा दिया, आप इसका डायग्राम बना सकते हैं। लाइट है, स्पेसिमेन डाल दिया, एक्सटर्नल spectrum आ गया, Zeeman effect, right? On the Zeeman effect is divided on the basis of spin on the direction of applied field. Now in the on the basis of spin, S is equal to 0, that is called normal Zeeman effect singlet, और S is not equal to 0 जैसे T1 T2 लाइंस में देखा है, वो क्या anomalous Zeeman effect। normal for paired electrons ns2 ns np6 nt, ये fully filled है, ठीक है। so इसमें S is equal to 0 लेंगे, तो ये हो गया normal Zeeman effect। and when where there is half spin 1/2 है, तो वहां पे आप कहेंगे कि anomalous Zeeman effect। now डायरेक्शन ऑफ फील्ड अप्लाइड, डायरेक्शन परपेंडिकुलर टू द फील्ड, अगर परपेंडिकुलर टू द फील्ड है, डायरेक्शन ऑफ फील्ड अप्लाइड के परपेंडिकुलर आप देख रहे हैं, तो ट्रांसवर्स जीमान इफेक्ट कहेंगे। इसमें प्लेन पोलराइज्ड होगा। अब ऊपर भी हमने देखा कि 3 प्लेन पोलराइज्ड हो रहा था इन टर्म्स ऑफ नॉर्मल जीमान इफेक्ट। एंड एलोंग फील्ड देख रहे हैं तो लॉन्गिट्यूडनल हो रहा है। इसमें सिर्फ और सिर्फ जो है +-1 होता है, इसमें सर्कुलरली पोलराइज होता है, करेक्ट। ये अगर एलोंग लॉन्गिट्यूडनल टू द फील्ड, ध्यान रखिए लॉन्गिट्यूडनल है तो सर्कुलरली पोलराइज्ड, करेक्ट। और अगर ट्रांसवर्स है तो प्लेन पोलराइज्ड, ठीक है। पीटी ऐसे कर याद कर सकते हैं, पीटी ट्रांसवर्स है तो प्लेन पोलराइज्ड, और एलसी, ठीक है, जो भी है जैसे भी याद कर ले। अच्छा, एनर्जी वी हैव ऑलरेडी डिस्कस। एनर्जी क्या है, माइनस ऑफ ई इज इक्वल टू माइनस ऑफ म्यू डॉट पी, राइट, म्यू डॉट पी। तो यहाँ पे म्यू जे, जे के डायरेक्शन में म्यू जे डॉट बी। सो आप देखिए म्यू जे इज इक्वल टू वॉट, E/2m जी जे जे, है ना। मतलब जैसे म्यू एस इज इक्वल टू क्या होता है, E/2m जी एस एस, उसी तरह म्यू एल इज इक्वल टू माइनस ऑफ E/2m जी एल एल, ठीक है। नाउ जी एल की वैल्यू 1 होती है, जी एस की वैल्यू 2 होती है। उसी तरह म्यू जे इज इक्वल टू वॉट, E/2m जी जे जे। सो नाउ व्हेन वी आर टेकिंग द along z डायरेक्शन, सो इसका आइगन वैल्यू क्या होगा, जैसे जे स्क्वायर का क्या होता है, जे जे प्लस 1 एच क्रॉस, राइट, एच क्रॉस स्क्वायर, देन जे जेड इज इक्वल टू एम जे एच क्रॉस, राइट, mjs को। तो now j interacts with b splitting into, अब ये हो क्यों रहा है, this why this is happening, because j is interacting with b and splitting into 2j plus 1 components। आप देखिए बहुत इंपॉर्टेंट बात मैं बोल रहा हूँ, ये components यहाँ लिख रहा है क्योंकि because we are discussing about Zeeman effect that is being based on external magnetic field। L है तो म्यू एल है, L है तो म्यू एल है, E/2m जी एल एल, S तो म्यू E/2m जी एस एस, म्यू j E/2m जी एस जे जी जे जे। अब क्या है, नाउ वी आर टॉकिंग अबाउट वीक फील्ड। वीक फील्ड इज 0.1 टेस्ला टू 1 टेस्ला के आसपास। इन वीक फील्ड एलएस कपलिंग इंटैक्ट, एलएस कपलिंग जो है इंटैक्ट होता है, एंड क्वांटाइजेशन ऑफ जे, जे की क्वांटाइजेशन होती है, वट एवर जे वी आर गेटिंग, फॉर एग्जाम्पल 2p3/2, ये जो जे है इसकी क्वांटाइजेशन हो जाती है, बहुत सारे वैल्यूज अलग ओरिएंटेशन आ जाते हैं, ठीक। और नाउ इन वीक एलएस कपलिंग, क्यों वीक, बहुत इंपॉर्टेंट बात है, बिकॉज इफ द वीक फील्ड इज नॉट देयर, द स्ट्रॉन्ग फील्ड इज देयर, तो वहाँ पास्ट एंड बैक इफेक्ट होगा, बिकॉज एलएस कपलिंग विल नॉट बी इंटैक्ट। अभी देखते हैं एलएस कपलिंग कैसे इंटैक्ट है। यहाँ पे एल प्लस एच इज इक्वल टू जे, राइट, ये है म्यू इज इक्वल टू म्यू एल प्लस म्यू एस, मतलब दोनों E/2m L plus 2s। now because L plus S coupling is intact, then we are this will constitute to J, तो यहाँ J plus S आएगा, राइट। और यहाँ पे 2s क्यों आया, E/2m याद है, E/2m GSS, यहाँ पे 2, बिकॉज GS की वैल्यू 2 होती है तो यहाँ 2s आ गया, राइट। एक J, एक L के साथ चला गया और एक बच गया। नाउ यहाँ पे थोड़ा आप देखिए, वी हैव टू कैलकुलेट द मैग्नेटिक मोमेंट इन द डायरेक्शन ऑफ जे, राइट। तो म्यू जे जे कैप लिख सकते हैं, राइट। इसमें कुछ नहीं किया, म्यू जे डॉट जे कैप किया, जे के डायरेक्शन में, जे के डायरेक्शन में फुल लिख दिया, तो यहाँ डिवाइड भी कर दिया, तो एक्चुअली यही चीज को लिखा हुआ वेक्टर्स की, बस ये। नाउ हम ऐसा कर क्यों रहे हैं, बिकॉज वी वांट टू पुट द वैल्यू ऑफ म्यू फ्रॉम हियर, दैट हैज टू बी लैंडेजी फैक्टर निकालने के लिए कर रहे हैं, साफ बात। जे प्लस एस डॉट जे, जे डॉट जे, जे स्क्वायर, जे स्क्वायर चल जाएगा, कट जाएगा, तो इट विल बी 1, एंड एस डॉट जे बाई जे स्क्वायर जे, राइट। नाउ सी the form, this is also जैसे earlier we have the form mu s is equal to what, E/2m GSS, right। now E mu L is equal to minus of E/2m GLL, right। now we have the form that it is becoming same form, E/2m, what is this, GJ, now we have to calculate GJ, So it will be calculated Gj is equal to 1 plus s dot j is equal to jj plus 1 ss plus 1 minus ll plus 1 by 2jj plus 1. How it will be coming? It will be coming from this. Yeah, simple है because what you know that L plus S is equal to J, then L plus S, then what? L plus S is equal to J. Now L is equal to what? J minus of S. So L dot L, we are squaring both side actually. J square plus S square minus 2 J dot S. Then J dot S becomes what? We are putting the eigenvalue problem. J plus 1 H cross plus S plus 1 minus L plus 1 by H cross, right, because yes, H cross square. So this will be the value, and mj H cross, so this will be coming. I hope you have understood it. If not, let me know, because same value H cross will be cutting out, right? So moving ahead, so this is called the Landry factor. Mu j is equal to E by 2 mgjj. We have calculated Landry factor from here. Now energy shift, what will be the, sorry, this is not a vector, this is not a vector, this is energy. E is equal to minus mu j dot b, right? Mu j dot b. Now we know that we have applied magnetic field in the z direction, suppose. Okay, so we have to take the z direction component of mu j. So z direction component of mu j we have to take. So it will be uh, mu j mj, right? This will be mu bb gj mj, because we have calculated mu j from here. Mu j E by 2m gjj, right? So when we take mu jz, right, so we have to take E by 2, these are constants, gj j jz. So what jj is, z is equal to mj h cross, right? So we are putting it here. So this will be mu bb gj mj. So it will be dividing. Now the splitting, we have to see the splitting, how many components are coming. So for delta E, how many component? Delta gj mj, energy levels defined by quantum number j. So total quantum momentum, total angular momentum, right? Energy sub levels defined by sub levels are defined by mj. Mj will be taking, assuming value from minus j to plus j. Will be everything will be clear at the end of the lecture. I'm okay. I hope till now things are good. So now selection rule is what? Delta mj is equal to 0 plus minus 1. Energy sublevels are defined by minus delta mj is equal to minus j 2 plus j. So 0 is what? Is 0 is pi components, and plus minus 1 is sigma components. Now in normal Zeeman effect, what we have seen is like there are only three components. Why three components? In normal Zeeman effect, we have S is equal to 0. When we have S is equal to 0, J is equal to L, because J is equal to S, L plus S. When S is equal to 0, then J is equal to L. So earlier also in the first line itself, we have studied in normal Zeeman effect singlet. This is called singlet, explained through classical physics. Earlier we were talking about the anomalous Zeeman effect. This is the normal Zeeman effect. Between S is equal to 0, Jj is equal to 1. You can also see that Gj is equal to 1, because this will be 0, and 2, this quantity will be 0. So Gj is equal to, actually Gj is becoming Gl, and we know that Gl is equal to 1. So it has only three components. You have to remember this value. We can also see how it has come. Mu bb, it is mu bb gj mj plus minus 1, gj is equal to 1. So mu bb is what? Mu bb, mu Bohr magnet E H cross by 2m into b. So H is equal to what? H by 2 pi. So when we write, then eb by 4 pi m, this is it, right? And this is written in terms of frequency. We have already said that delta mj is equal to 0 is pi component, delta mj is equal to plus minus 1 is sigma component. Now what is the significance of gj? And calculating magnetic moment, we have to know gj. Zeeman shift calculation, it is helpful. Energy shift is equal to mu bb, gj is equal to mj. Anomalous, this is through quantum mechanics we can get between as triplet states. This anomalous happens usually more than three components. Now let us see about the sodium atom. We have already d1 d2 lines. When d1 d2 lines are being placed in external magnetic field. This is external magnetic field. Then it splits into different components. Let us see. This is our spin orbit coupling. Spin orbit coupling, not LS coupling, because single electron hydrogen like atom. Now this will be split into 3p by 2, 2p 3 by 2, 2p half, and again this 3 by 2 minus split into 2j plus 1. Now 2j plus 1, 3 by 2 into 2 plus 1, it will be 4 components. So mj to minus of minus j to minus of j. So mj will become mj will be minus j to, or minus j to j plus j to j, matlab whatever you want, right? So this is 3 by 2 plus 1 by 2 minus 1 by 2 minus 3 by 2. So this is split into 4, right? Now this will be splitting into 2, because 1 by 2 minus 1 by 2 mj, 1 by 2 minus 1 by 2, right? Now you can calculate ej, energy shift. Okay, what was that? E is equal to mu vb gj mj. So what is mu b? Mu b, let it be mu b, this corner gj you have to calculate gj, and mj is 3 by 2. Gj we can calculate, gj is equal to what? 1 plus jj plus 1 plus of ss plus 1 minus of ll plus 1 by 2 jj plus 1. So in this case what will be, we have 1, you can calculate 1 plus j, you can put the value of 3 by 2, s is equal to half, s is equal to half, because you can say 2s plus 1 is equal to 2, so s is equal to half, s, and l is equal to 1. Put all this value, you will be getting this value, right? Moving ahead, this is, we can mention that due to spin orbit interaction, and this is, now we can see there are 4 lines. There are 4 lines from D1, 4 lines from D1, 6 lines from D2. So you can see the pattern, and remember how the lines are. You can also draw, because you know delta mj is equal to 0 plus minus 1. See, let's see about this one. This one we'll seeing about the D2 lines. How is, so minus 1 by 2, minus 1 by 2, it will go to plus 1 by 2. If it goes to minus 1 by 2 to minus 1 by 2, minus 1 by 2 to plus 1 by 2, okay, it can go, because see from here it has gone from here, because there is it is not violating delta mj is equal to 0 plus minus 1. But suppose 3 by 2 goes to minus 1 by 2, 3 by 2 minus of minus 1 by 2 to 1 by 2, it would be like 4 by 2. So can it be happen? No, it cannot, because mj, delta mj is here too, and we need that delta mj is equal to 0 plus minus 1, right? So this is pi components. The pi component delta mj is equal to 0. Sigma components is a delta mj is equal to plus minus of 1. So total 10 lines in the spectrum. So there are total 10 lines in the spectrum. This is a very important question. It happens to come most of the time in the examination. Now we are going ahead with the Larmor precision. Larmor precision is a very important term, and you need to remember the formula, because questions are coming. Rotation of angular momentum vector along the applied magnetic field. So there's a magnetic field, and angular momentum vector is rotating. In this case, we have discussed those things. Yeah. So torque is equal to omega cross j. We can also calculate, and omega is like precessional angular velocity. So delta j is what we have drawn. Let's zoom in. This what we have, angular momentum j. After some time it passes it, this would be j plus delta j, and vector addition I am doing, this is delta j, this is, let's see, theta, then this is 90, then this will become j sine theta, right? This is delta phi, then delta phi is equal to theta is equal to l by r, delta l by j sine theta. What, that is what it is written, right? Now omega, what is the velocity omega? So omega is this, omega is delta theta, delta phi here by delta t. So what we are trying to say, delta, and what uh, we are putting this value here. So delta phi is delta j by j sine theta, and limiting it to t, dj by dt, dj by dt by j sine theta. So dj by dt is what? Torque is equal to what? Change in angular momentum, dj by dt by j sine theta. So we can also write torque is equal to omega cross j, that we have already written earlier. Now dj by dt is equal to torque. Torque we know, torque we know that mu cross b, we know the formula of torque, mu cross b, right? Torque is equal to mu cross b. So we are writing mu j cross b, because we are taking the magnetic moment corresponding to J angular momentum. So we know from earlier mu j is what, minus of E by 2m J, right? So it will be like J B sine theta, angle between the B and J. So dj by dt is equal to minus of E by 2m GJB J sine theta. We have replaced this. So this will become omega dj by dt is equal to what? Uh, yes, here we are putting this value. Here we are putting this value. So when you put this value, gj will be vanishing because it is downside. Gj sine theta will be vanishing. Now omega p will be this value. Correct? You are getting it right? Suppose delta, we are putting the value. Delta phi is equal to dj sine theta dj minus E by 2m gjj and j sine theta by j sine theta. So only this value will be opening. So you have to remember this formula. You have to remember this formula, very important. So omega, and this is like omega into j sine theta. So omega p precision E by 2m gjb. So this is directly numericals are being asked from this. So omega p minus of E by 2m gjb, where gj is like we know Landis factor, we have already calculated. By Larmor theorem, the angular velocity of precession is, ये लिखने के लिए आप लिख सकते हैं angular mu l by l into b. ठीक है, remember this. Space quantization of angular momentum हो रहा है. We can see that space quantization of angular momentum is happening components में टूट के. This is like nuclear magnetic resonance. We'll see about this. Nuclear magnetic resonance इसी के concept पे based है, जहाँ पे external magnetic field you provide, where you provide external magnetic field, and when the frequency of the provided field matches with the internal frequency, it gives the maximum output in the source, in the viewing screen. Okay, so we'll see this later. The concepts are same. EBB, mu j, normal Zeeman effect. We are looking at. We are now again we are. I am just summarizing it out. E is equal to minus mu dot b. So it will be mu bb. We have already calculated. You have to remember this mu naught plus EB by 4 pi m Zeeman shift. Yes, this is very important. This is Zeeman shift because in the questions it is directly asked, calculate Zeeman shift. So EB by 4 pi m, and when you calculate in terms of wave number, you have to divide by this is in frequency and you have to divide by c. This is called Lorentz unit. This is very important thing. This is called Lorentz unit, and s is equal to 0, j is equal to l. Everything, I think this is clear. We have already discussed those. Calculation, yeah, we can see this question. Calcium line of wavelength, this one, going to p to s, exhibits normal Zeeman effect splitting. Normal it has already written, so it will be splitting into t when placed in uniform magnetic field of 4 Weber per meter square. Okay, unit of magnetic field. Calculate the wavelength of three components normal of the Zeeman with a pattern separation between them. So we know that p will be splitting in three components. P will be splitting in three components, plus 1, because ml is equal to plus 1 0 minus 1. It will be like that, and this will be mu bb. Again this will be mu bb, we have earlier seen. So we can have three wavelengths going according to this. We can hc by lambda 3, hc by lambda 4. Separation is like mu b eb by 4 pi m. So this is all about Zeeman effect. I will just go through one of the notes if I have something missed. So Zeeman effect. So yes, we have discussed Zeeman in 1925. I will not spy. It may happen that you have to line components have to be made, but it is not specified that it is normal or anomalous. So you can very see where this is 1. So uh, if this is 1, then what is like s is equal to 0, so this will become normal Zeeman effect. But when you are talking about 2d dy5, so it's obviously that 2s plus 1, in this case s is equal to half, this will correspond to anomalous Zeeman effect. So you have to see by looking at this value. So we have taken transverse, we have taken transverse direction longitude pt, we have plane polarized. When we are looking at the transverse direction longitude, everything is done. So sublabels we are called uh, sublabels in 2j plus 1 sublabels. Essential requirements are what? Weak external magnetic field. Why weak? Because we know that otherwise ls coupling will break. Quantum mechanical treatment is like we have already done, as l gll 2s, and torque is equal to mu cross b. Everything we have done. New Zeeman effect is We have done all those mu j e by 2m gjj, as we have calculated the land ag factor. J is called mu j, yes, we have done all those. Mu bb gj mj. Selection rule we have done. Delta mj is equal to 0 plus minus 1. In normal and transverse Zeeman effect, selection rule delta where, and longitudinal Zeeman effect we have seen delta mj is equal to 0 are suppressed, and circularly polarized we have already seen in the first initial part of our lecture. So when delta is equal to, this is the corresponding to ml normal Zeeman effect. Land ag factor, again we have seen this value, d1 d2 lines splitting into components, 10 components, sodium d1 d2 lines, this is it, right? So energy, for example, you have to calculate this. So what you will do, because it is going down, then delta e2 minus e1, this is like if e1 minus of mu bb by 3h, mu bb by gj mj, because you have to take care of this. This is 3h, so this is 3h, this is h, corresponding to this. Energies are written, you can calculate accordingly. Observation we have already done all those. So this I just want to summarize this, that's why I have opened the study. Normal anomalous Zeeman effect is typically observed in transverse Zeeman effect. Okay, anomalous Zeeman effect is typically observed in transverse, where we get plane polarized, right? Gyromagnetic ratio mu b by l, this is all. These are few questions, we can do this. Yes, so yeah, at times it is asked for give the difference between normal Zeeman effect and anomalous Zeeman effect. So these things we have in normal Zeeman effect, we have three components always. EBB by 4 pi m, the separation. Again, these things we have done. Okay, the very important thing I have just to point out, in normal Zeeman effect, this normal Zeeman effect, suppose it has split into these many lines, but what happens there, you might be seeing that there are so many lines here, but the energy corresponding to these lines will summarize to only three lines. What you are getting, okay, all five lines knew not only one component same frequency, you are getting it. There are many lines, but that many lines corresponding to one frequency only, so it will give only three components. Okay, so this is, you can make this diagram mu bb by h, mu b by eb by 4 pi m. We have already done all this. EBB by 4 pi m, this is called Zeeman shift. This is in frequency unit, and when you divide by c, when you try to get it in the wave number, this is called Lorentz units. Okay, this is it. Thank you very much. Thank you for watching. If any improvements are there, if I have done any mistake, so please let us know. Thank you for watching.